Hey boys and girls, today your math lesson is going to be a recording. You're going to be following along in your math book, volume 1, page 145 to 148. Go ahead and get that out and get a pencil and get ready to go. Okay, today we're going to be using the area model and the distributive property to divide. So those are two things we've worked with separately, but today we're going to combine them to do division problems. I'm going to remind you about the ways we've used the area model before. Okay, we have used the area model to find area width, where we said area equals the length times the width, and we found the area of a rectangle. We took that model and we used it to solve multiplication problems too, so we call this the area model. If we were going to solve a problem like 7 times 45 equals a product, we expanded 45 into 40 plus 5 because that was easier to multiply by. The 7 times the 40, 280, and then the 7 times the 5, 35. And then we added these two together to give us 315. So we could find that answer, and this inside part is sort of like finding the area. With this is the length, and that is the width. So we call it the area model to solve that multiplication problem. So that's what we mean by the area model. Now you've heard that word distributive property before too. So we've used distributive property of multiplication. Let me show you an example. I'm going to use this example to show you distributive property. Okay, with the distributive property, I'm using the same problem, 7 times 45. I keep my single digit 7 the same, and I keep my multiplication sign. But instead of multiplying by 45 all at one time, I break that down into two smaller numbers that are going to be easier to multiply by. I've picked 40 plus 5. Now first I multiply this, I draw my rainbow, 70 times 40. And write it down here, then my addition sign, and then 7 times the 5, and write it here. So I get those same two partial products, 280 and 35. I add those together to 315. So this is another way that we could solve a multiplication problem. Distributive property. Okay, so in this lesson, we're going to combine both the area model and the distributive property to divide. So go ahead and box in your I can statement. I can solve multi-digit division problems using the area model and the distributive property. Okay, right here we have a couple of little sheep. And I don't know if you've ever been to a farm that raised sheep before. But sometimes on those farms, the little sheep will be out grazing all day, but at night they have to bring them in and put them in like a pen for safety. Or if they're ever going to be cutting all this wool off of their body, all that little fur, that's called shearing. They shear sheep. They have to get them in a pen so that they don't all run away. So this story is about building a pen for holding sheep. So first we're going to read through it so that we understand what this situation is about. Sean is building a rectangular pen for holding sheep. And a pen is just a fenced-in area. The area of the pen needs to be 63 square feet, and the pen must be 3 feet wide. How long should the pen be? Okay, well, I understand the situation here. Sean's building some pens. And I need to know what numbers, what quantities I'm going to be working with. Well, I know how big the area is. The area needs to be 63 square feet. So that's going to be that inner space inside of the pen. It needs to be 63 square feet. The pen must be 3 feet wide. How long should it be? So I know it's got to be 3 feet wide. And I know if I multiply that by the length, that's going to have to give me my area of 63 square feet. All right, so I'm going to think about some possible ways to do that. Maybe I could draw an area model on this grid paper to show those. So I know that I'm going to make a model that's 3 feet wide. So I'm going to use 3 of these squares to show 3 feet wide. So you can do that on your paper. Count down 3 and make a width of 3 feet. I'm just going to write 3 feet there. Okay, now I'm not quite sure how long this length has to be, but I know it has to be 63 feet. Well, I know that 3 times 2 is 6. So I'm thinking to myself, I know that 3 times 2 is 6. So 3 times 20 is going to be 60. So if I break 63 into 60 plus 3, I know that 3 times 20 is 60. So I'm going to count out 20 here. And so I know 3 times 20 is going to be 60. 3 times 20 is going to be 60. All right, well, I still need 3 more feet for those sheep. I can see if I add on one more spot right here, just one more little length here, it's 3 feet wide, 1 feet wide. That's going to be 1. 3 times 1 is 3. So I know 3 times 20 is 60, plus 3 times 1 is 3. 60 plus 3 equals 63. So I know that my length is going to be 20 plus 1, which is 21. So here I've used this model to break down 63 into easier numbers that I can divide by 3 to figure out what the length is. All right, let's finish copying that down and let's move on to the next problem. Okay, this is page 146. And again, we're staying with that sheep theme, because here we want to read through it and see if we understand what the question is about. I see this little package over here. It has some wool inside of it. It must be sheep wool. And it says 92 kilograms. All right, kilograms is metric system for weight. So instead of saying 92 pounds, they're saying 92, what they're measuring with the metric system, 92 kilograms. Reggie shears sheep for their wool. He places all of the wool in this bag. So he cut all the hair off the sheep and he stuck it in this bag. Each sheep provides 4 kilograms of wool. So from each little sheep, he gets this much wool. How many sheep does Reggie shear? Okay, well, I know if I got this whole bag of wool and I divided it out over groups of 4, every group of 4 would stand for one of the sheep. So if I find that quotient, I'm going to know how many sheep there are. All right. Find 92 divided by 4. Well, question A asks us how we can break apart 92 into smaller parts that are easier to divide by 4. Okay, well, if I break it into 90 plus 2, 90 is not an easy number to divide by 4. So I'm not going to use that. That would be the first thing I would guess. Now they're suggesting something here. They're suggesting I break it into 80 and another number. Now why would they be suggesting that? Well, if you think about your times tables, I know 4 times 2 is 8. If I know 4 times 2 equals 8, then I know 4 times 20 equals 80. And that's very close to 92. So I'm going to break 92 into 80 and plus some other number. All right, well, how much is left? If I say 92 subtract 80, go ahead and subtract that. 2 minus 0 is 2, 9 minus 8 is 1. So I know that 92 is equal to 80 plus 12. Is 12 also an easy number to divide by 4? Well, it is. Okay, and why do I say that? Because I know that 12 is a multiple of 4, because 4 times 3 is 12. All right, so now I'm going to use that distributive property. I'm going to say 92 divided by 4 is equal to 80 divided by 4 and 12 divided by 4. Well, they're going to have me step it out here. 80 plus 12 divided by 4. So I'm going to first think about 80 divided by 4 plus 12 divided by 4. Okay, that's using that distributive property. Now they've given us a piece of grid down here so that we can do the area model on that. All right, well, I know this number in here. We've broken apart 92 into 80 plus 12. So this has to equal 80. And this part over here is 12. I can count the squares and see that it's 12. I could count all those squares and see that it's 80. All right, now they're saying that the area is the number of rows, 4 rows, times the number of columns. Well, 4 times what is 80? Well, I know 4 times 20 is 80, because 4 times 2 is 8, and annex that 0. Plus, 4 times what? 4 times what is 12? Well, I know 4 times 3 is 12. 4 times 3 is 12. So here I've completed my model. Now I need to see, what does it mean? Well, I know 80 and 12 is 93. I already knew that. What did I not know? I didn't know what this length was up here. 4 times what number is equal to that? Okay, well, I know that if 4 times 23 is equal to 92, then 92 divided by 4 is 23. All right, let's break this down a little bit more. How does this area model represent the whole dividend and the dividend broken into smaller parts? Well, I can see that this entire model here, this entire area, is the whole dividend of 92. When it was split right here, that represents the dividend being broken up into 80 plus 12. So the whole area has 92 squares. It is broken into 2 smaller regions. Or rectangles. Of 80 plus 12. So we're representing that area in 2 ways. How does the area model represent the divisor? Well, I can see that the length over here, both of these areas have a length of 4. Both of these areas have a length of 4, and that represents the divisor. Both rectangles have 4 rows. These are our rows here, 4 rows. All right, so how does it show the whole number quotient is equal to 20 plus 3? How do I know that the quotient, the answer, is equal to 20 plus 3? Well, that's because I found the missing length. I knew the width, I knew the area, I found the missing length to this problem. So we just added 20 plus 3 to find the missing length. Which is the quotient. All right, so finally, 92 divided by 4 is 23. So Reggie shears 23 sheep. I wonder if it's fun to shear sheep. Probably not as fun as doing long division with the area model and distributive property. All right, let's turn to the next page. Okay, if I can find it. All right, this is page 147. Step it out. Because they're focusing on this vocabulary, the distributive property. And this is one challenging definition, but we can understand it. The distributive property states that multiplying a sum by a number is the same as multiplying each add-in by the number and then adding the products. An example. So the example is going to help us understand this definition. If I have 10 plus 8 times 2, that would be equal to multiplying the 10 times the 2 and then adding it to the 8 times the 2. Now that's the distributive property of multiplication. So they're telling us now that the distributive property also applies to division. Look at this example. If I have 10 plus 8, or 18, which has been split up into 10 plus 8, and I'm dividing it by 2, that will be the same as saying 10 divided by 2 plus 8 divided by 2. All right, so we're going to use that distributive property to solve this problem. Now, luckily, I can see that this one's going to be a pretty easy one to split up. Use an area model and distributive property to find 217 divided by 7. First of all, break apart 217 into numbers that are easier to divide by 7. Now, I said this one's going to be a little bit easier because I'm already seeing something. If I know that 21 is divisible by 7. I know this because 7 times 3 is 21. 21 is a multiple of 7. So if I know that 7 times 3 equals 21, And I know 7 times 30 is equal to, and next at 0, 210. And I know that 210 is close to 217. So I'm going to split 217 into 210, and that leaves me 7. 210 plus 7 is the same as 217. All right, so these are easier numbers. They're friendly numbers. We're going to use these easier numbers to divide. All right, so instead of 217 divided by 7, I'm going to say 210 plus 7, and I'm going to divide each of those by 7. So rainbow time, 210 divided by 7 plus 7 divided by 7. Double rainbow. Okay, now I know that 210 divided by 7 is going to be 30. I know that because 30 times 7 is 210. That's the only reason I know that. And then 7 divided by 7 is 1. And then 30 plus 1 is 31. So I know that 217 divided by 7 is equal to 31. And now we get a chance to use this area model over here. Well, what did we know? We knew the divisor was 7. We knew the dividend was 217. We split 217 into 210 and 7. And then we said, 7 times what is 210? 7 times 30. 7 times what is 7? Well, 7 times 1. Alas, we get a missing quotient there of 31. All right, let's go on down to check understanding. Keep rolling along. You're doing fine. Or at least I am. Okay, so AJ has 54 pounds of wool. He uses 3 pounds to make blankets. How many blankets can he make? Model to find 54 divided by 3. Okay, make sure I understand this. He's got 54 pounds of wool, and he's going to make blankets out of them. Every blanket takes 3 pounds of wool. So if I split 54 into groups of 3, I will know how many blankets AJ can make. All right, and I have a handy dandy piece of grid paper over here. I know what my divisor is going to be. I know that 54 divided by 3 is the same thing as 3 times some number equals 54. So I know that's going to be like the inside area. I know what the width is going to be, 3. Just need to find out what the other factor is going to be at the top. All right, so I'm going to make my grid 3 boxes wide. And now I need to think about 54. I'm going to break that into numbers that are easy to divide by 3. I could break it into 50 plus 4. That's the same as 54. But 50 is not easy to divide by 3. Why? Because there's no multiple of 3 that's 54. Or 50, I mean. Or even a 5. All right, so I'm going to think of something that's a multiple of 3 that's close to 54. I know 3 times 3 times 1 is 3. So I know 3 times 10 is 30. So 30 is close to 54. I know 3 times 2 is 6. So 3 times 20 would be 60. So that's too big. So I know I'm going to have to break this into 30 plus another number. 54 will break into 30 plus what other number? Well, 54 minus 30. Subtract that and find the difference. All right, I got 24. So 54 is the same thing as 30 plus 24. So I know this length over here, this area in here has to be 30. So I have to think 3 times what is 30? 3 times 10. So I count over 10 boxes. Count over 10 and mark it off. And there we got a nice little area model to show that 3 times 10 is 30. The other part is 24. So I know this section needs to be 24. Well, is 3 times anything 24? Well, lucky for us, it is. I know that 3 times 8 is 24. So I need to go over 8 more squares. All right, so I already knew what my area was. My area in there inside was 54. That was my total. I divided it by 3. Now what I found out was this mess across the top here. All right, what is 10 plus 8? Well, that equals, yeah, baby, it's 18. So know that 54 divided by 3 is 18. So, AJ, you can make 18 blankets. All right, now I am the first to tell you that this is a very challenging method to understand, which is why we are stepping it out together. But hopefully it makes a little bit of sense, and you can see how it ties into the area model with multiplication. Okay, so we're going to do 72 divided by 4. 72 divided by 4. I could break 72 into 70 plus 2, but those are not easy numbers to divide 4 into. Nope. I don't see anything related to a 7 or here. I know that 4 times 1 equals 40. Excuse me, I'm lying to you. 4 times 1 is 4, but 4 times 10 equals 40. You see, I'm using that pattern of 0. And 40 is close to 72 without going over. If I did 4 times 20, that would be 80, so that's too big. So what does that tell me? That tells me I can break 72 into 40 plus another number. 40 plus what is 72? Subtract it out and figure it out. 2 minus 0 is 2, 7 minus 3, so I know it's 32. So I'm going to have to do 40 divided by 4, and then 32 divided by 4. 40 divided by 4, easy, is 4. 32 divided by 4, well, here's 32 divided by 4, it's going to be 8. And then I add these two, 8 plus 4 is 12. So what does that tell me? 72 divided by 4 is 12. Okay, 115 divided by 5. Well, I can break 115 into 100. That can divide by 5 plus 15. That will work. So I'm going to break it into 100 plus 15. That's this number, broken up smaller so I can divide it more easily. I'm going to say 100 divided by 5, and then 15 divided by 5. And now I know that 100 divided by 5 is equal to 20, because it takes 20 nickels to make $1. So 100 divided by 5 is 20. And then 15 divided by 5 is 3. So I'm going to add these two together and get 23. So 115 divided by 5 is 23. All right, now I know some of you all think, hey, I can do this by myself. I'm going to try it. If that's the case, quietly work on this on your own. But I'm going to be running my mouth and going over this just to make sure everybody feels good about these problems that we're working out. First of all, we're going to read it and make sure we know what it's talking about. Deborah raises alpacas for their wool. She feeds each alpaca 7 pounds of food each week. She uses 98 pounds of food each week. How many alpacas does she have? Use an area model to find 98 divided by 7. Well, they've already told me I'm going to use division here, but I want to still make sure I can figure that out for myself in case they didn't tell me. I know she uses this much food each week to feed all of her alpacas. By the way, I had a pair of socks made out of alpaca wool, and they're my favorite socks. Very comfy. So all of her alpacas eat 95 pounds of food. How much does each one eat? Well, each one eats 7 pounds. So if I take this 98 and I divide it up by 7, each group of 7 stands for 1 alpaca. So 98 divided by 7 will tell me how many alpacas that I have. Okay, the first thing I want to do is I want to break this up into numbers so they're going to be easier to divide by 7. I'm not going to divide it into 90 plus 8 because 90 is not easy to divide by 7. But I know 70 is. So I'm going to make this 70 plus some other number to equal 98. Well, what 70 plus what is 98? Well, subtract out 70 and figure it out. 9 minus 7 is 2. So I know that 70 plus 28 is equal to 98. All right, so my area model, my area has to have 98 boxes in it. What is the length of my area going to be? 7. So I'm going to go 7 boxes down. That's going to be my length, 7 boxes. Now I'm splitting 90 up into 70 plus 28. So my larger rectangle is going to have 70 in it. Well, I know that 70 times what number, 7 times what number is 70? Well, I know 7 times 10 is 70. So I know I'm going to need a 10 up there at the top. Count 10 boxes. And box it in. So what does that show me? That shows me that 7 times 10 is 70. There are 70 little boxes in here. All right, now I still need to do the 28 because this has to be 98 all inside of that area. So 70 plus 28 more. So I need to think 7 times what number? 7 times what number is 28? Well, I know 7 times 4 is 28. So I know I need 4 boxes at the top. Okay, so that is 28 more boxes. So here we have our total that we knew, the 98, but we wrote it as 70 plus 28, so we could figure out this part of it. 7 times 10 is 70, 7 times 4 is 28. So that means that 98 divided by 7 is equal to this length up here, 10 plus 4. 10 plus 4 equals 14. All right, so I know she has 14 of the alpacas. And that's using the distributive property in area to solve that division problem. Here we have the same thing. me to break 126 into two numbers that are easy to divide by 3. Well, I know 12, so I'm going to break it into 120, and then plus how many more? 6. 120 plus 6, 126. So I know that 123 divided by 3 will be 120 plus 6 divided by 3. Now I'm going to use my rainbows. 120 divided by 3, first of all, plus my 6 divided by 3. Now I need to solve each part. I know 120 divided by 3 is 40. Plus 6 divided by 3, which is 2. Add those two add-ins together, I get 42. So 126 divided by 3 is equal to 42. Okay, there are 3 problems down here that you're going to solve. If you like to work those on your own or work them out with me, it's your choice. Just work quietly. Actually, you're probably not going to have enough time to do these. So I want you to try these for homework or finish these in class. Okay, there is some small grid paper in the grid paper tray. It's not the large grid paper, it's the one with small grids on it. You'll just have to tear a piece off of there to help you do these 3 problems. Okay, good luck on that. And see you tomorrow.